Hello students, in 10th class we have the first chapter real numbers. Before going to understand the concept of real numbers, in your previous classes we have learned about real numbers operations on real numbers, multiplication, division, addition, subtraction, their decimal expansion and laws of exponents for real numbers. In this chapter we will continue our study on real numbers and begin with two important properties of positive integers, namely Euclid's division lemma and the fundamental theorem of arithmetic. Once again we will revise the concept what you learnt in your 9th standard. What is natural number? What is natural number? The numbers which are used for counting are called natural number. The symbol used to represent natural number are n. We know that. And what is whole number? Whole number used to represent the symbol W. The natural numbers together with 0 are called whole numbers. What are integers? Integers can be represented by the symbol Z. The numbers which consist of negative of natural numbers and whole numbers are called integers. What are prime numbers? A natural number which is divisible by 1 and the number itself is called prime number. What are composite numbers? A natural number which is not prime is called composite number. One is neither prime number nor a composite number. Let's come to the very most important concept, rational number. What is rational number? A number which can be expressed in the form P by Q, where Q does not equal to 0 is called a rational number. All the terminating and non-terminating recurring decimals are rational numbers. The symbol used to represent rational numbers are Q. What are irrational numbers? An irrational number is a non-terminating and non-recurring decimals which cannot be expressed in the form of P by Q, where Q does not equal to 0. Example, root 2, root 3, root 5 and pi, so on. Next come to the very most important definition, real numbers. What are real numbers? Real numbers, the symbol used to represent real number is R. Rational numbers and irrational numbers taken together are called real numbers. Thus, every real number is either a rational number or an irrational number. Have you understood, student? What is real number? Real numbers or real numbers, it is the set of rational numbers and irrational numbers. Rational numbers and irrational numbers are taken together are called real numbers. Thus, every real number is either a rational number or an irrational number. Let us understand first the meaning of lemma and algorithm. So, totally we have 4 topics in the real numbers chapter. What are that 4 topics? First one, Euclid's division lemma and algorithm. Topic 2, the fundamental theorem of arithmetic. Topic 3, revisiting rational numbers. Topic 4, revisiting rational numbers and their decimal expansion. So, first we should understand the meaning of lemma and algorithm. What do you mean by lemma? What is lemma? Okay, student, have you understood real number? Real number is a set of rational numbers and irrational number. Before going to understand the topics of real number, we should know some terms, some concept. What is that lemma? Lemma is a proven statement for proving another statement. What is lemma? A lemma is a proven statement for proving another statement. Mainly it is used in the case of geometry, especially in theorems. Example, you can understand through an example. Theorem, let's consider if m and n are any two whole numbers and where a is equal to m square minus n square, and consider the value of b 2mn and c is equal to m square plus n square. So we can say that a square plus b square is equal to c square. So this is nothing but Pythagorean triplet. To that we can supply the proof a square plus b square is equal to, substitute the values of a, b, c in the given statement. What is a? A is equal to m square minus n square. In the place a, if you put m square minus n square whole square plus, what's the value of b? The value of b here 2mn. B square is there, 2mn whole square. Then if you substitute and simplify, finally you'll get the answer c square, because it is in the form of a minus b whole square. Expand this formula, a square minus 2ab plus b square. Next, 2mn whole square is nothing but 4m square minus n square. Here m to the power 4 plus 2m square n square, because here if you see minus 2m square n square is there, here plus 4m square n square is there. You should subtract 2 from 4, you will get the answer 2m square plus 2m square into n square. Finally, it is in the form of a plus b whole square. That's why a here m square, b here b square. So a plus b whole square, it is in the form of a square plus b square. Then finally you will get the answer c square. This was a major result. Corollary. What is corollary? A, B, C are defined above. That means already here we defined what is A, what is B and what is C. From this theorem, we can derive the Pythagorean triplet. A square plus B square is known as A square plus B square, that is equal to C square. So, A, B, C are called a Pythagorean triplet. The result followed from this previous theorem. Have you understood? So corollary means it's already taken from this result. This is the result obtained from this previous theorem. Then come to lemma. What is lemma? Same thing. If you take m, the value of m is equal to 2 and n is equal to 1, then we get the Pythagorean triple. So what is lemma? Already we said. Lemma is a proven statement. Already it is proved. For proving another statement, already we said a square plus b square is equal to c square is known as Pythagorean triplet. Again we have to proving the statement by taking proven statement. Again we are proving another statement. That means we are giving some values of for m and n. Take the values. If m is equal to 2 and n is equal to 1, then we get the Pythagorean triplet. A, what's the value of a? So here a value m square minus n square. So it takes the value 2 square minus 1 square is equal to 4 minus 1 is equal to 3. Value of b is equal to 2 into m into n. So 2 into 2 into 1 is equal to 4. According to Pythagorean triplet, if you substitute, AC is equal to c square is equal to a square plus b square. Then a square value 4 and b square value 1. Then you'll get the answer 5. 4 plus 1 is equal to 5. So that is known as, it is already proven statement. Again we are proving another statement. So in the chapter real numbers, mainly we are going to discuss about 4 topics. Topic 1. What is the topic 1? Euclid's division lemma and algorithm. Second topic, the fundamental theorem of arithmetic. Topic 3, revisiting rational numbers. Revisiting rational numbers and their decimal expansion. Totally we have 4 subtopics in real numbers chapter. So we will discuss one by one. Today in this class we are going to discuss about the first topic. What is that first topic? Euclid's division lemma. We can solve the, we will discuss topic wise and then solve the problems based on these topics. So today we are going to discuss about the first topic, that is Euclid's division lemma and algorithm. Already we learned the meaning of lemma. What is lemma? Lemma is a proven statement. Lemma is a proven statement used for proving another statement. What do you mean by algorithm? Algorithm means an algorithm is a series of well-defined steps which gives a procedure for solving problem. What is algorithm? An algorithm is a series of well-defined steps which gives a procedure for solving a problem. What is Euclid's division lemma? What is Euclid's division lemma? For any two positive integers, let us take the two positive integers means any integer. We can't take so many integers. Just we have to take the integers a and b. For any two positive integers a and b, there exist unique integers q and r. For any two positive integers a and b, there exist unique integers q and r. Satisfy the relation a is equal to bq plus r, where r greater than r is always less than b and greater than 0. I'll repeat again the definition of Euclid's division lemma. What is Euclid's division lemma? For any two positive integers a and b, there exist unique integers q and r that has to satisfy the relation a is equal to bq plus r. A is equal to bq plus r, where r is greater than 0 and less than b. So we will understand through some example. Let us here take 37 is divided by 5. From which number we have to divide, that is known as divisor. What we have to divide, that is known as dividend. Or how many times it will divide, that is known as quotient. What will be left at the end of the division, that is known as remainder. Here 37 can be divided by 5. How many times? 7 times. 5 sevens are 35. What will be left at the end? 2. So here 5 is a divisor, 37 is a dividend, 7 is a quotient, 2 is a remainder. The same thing here we can write 37 can be written as 5 into 7 plus 2. Can we write now? 5 sevens are 35. 35 plus 2 is equal to 37. Like this one also. Here we can assume A here 37, B is 5. A always greater than B. Okay. So 9 5s are 45. Subtract 45 from 47. You'll get the remainder 2. Again here also we can write 47 can be written as 9 5s are plus 2. So 9 5s are 45 plus 2, 47 is nothing but A is equal to BQ plus R form. This is also A is equal to BQ plus R. The Q is a very easy you can keep in your mind, is a unique integers. Q is nothing but quotient, unique integer Q and R. R is a remainder. So then we understood what is Euclid's division lemma. We should express that is in the form of A is equal to BQ plus R. A is equal to BQ plus R form we have to express. That means it says that any positive integers is nothing but is a restatement of the long division process. It is a restatement of long division process. We learnt in your 9th standard, dividend is equal to divisor into quotient plus remainder. Have you understood, children? In the last class, once again revise the concept. Dividend is always equal to divisor into quotient plus remainder. That's why it is nothing but a restatement of the long division process. So another important point you have to keep in your mind, the unique integers q and r, nothing but quotient. What are the integers q and r? Q is nothing but quotient, r is nothing but remainder. So what according to the definition, For any two positive integers a and b, there exist unique integers q and r. What are the unique integers? The unique integers q and r nothing but the quotient and remainder respectively. Although you have to keep another one most important point, Euclid's division algorithm is stated for only positive integers. Euclid's division algorithm is stated for only positive integers, but it can be extended for all integers except 0. And third, very most important point, when a and b are positive integers, then q and r can take the values only from whole numbers. You have to keep this very most important point in your mind. I'll repeat again. The unique integers q and r are nothing but what are that q? Q and r is nothing but quotient and remainder. The Euclid's division algorithm is stated for only positive integers, but it can be extended for all integers except 0. When a and b are positive integers, then q and r can take values only from whole numbers. This is the very most important point you have to keep in your mind. This is about Euclid's division lemma. In the first topic only, we have discussed about one small concept, Euclid's division lemma. Next come to the another concept, Euclid's division algorithm. Algorithm, already you understand the meaning of algorithm is nothing but it is a well defined steps which gives a procedure for solving a problem. I'll repeat again, student. An algorithm is a series of well-defined steps which gives a procedure for solving problem. Now you understood the meaning of algorithm. Let's discuss about what is Euclid's division algorithm. So now you can understand what is Euclid's division algorithm. Euclid's division algorithm is a technique to find the HCF of two given positive integer. What is HCF? Highest common factor. So Euclid's division algorithm is a technique. What is the technique? It is a technique to calculate the HCF, highest common factor of two given positive integers. According to this, HCF of any two positive integers a and b with a always greater than b is obtained from the following steps. Is nothing but to find the algorithm is nothing but to find the HCF of any two given positive integers. Lemma is nothing but a long division, repeated long division process. What are the steps we have to follow? Step number 1. Apply Euclid's division lemma to a and b. That is, find the whole numbers of q and r such that we should express in the form of a is equal to bq plus r. Always we know that r is less than b and greater than 0. The remainder is always greater than 0 itself only. Step number 1. Apply Euclid's division lemma to a and b. That is, find the whole numbers q and r such that a is equal to bq plus r. R is less than b and is always greater than 0. Step number 2. If r is equal to 0, then b is the HCF of a and b. If r not equal to 0, apply the lemma to b and r. What is the step number 2? So first step, we should apply Euclid's division lemma to the given two numbers. Second step, while applying division lemma, if we get the value r, that means the remainder will be equal to 0, then b is the HCF of the given two numbers. If r does not equal to 0, then we have to continue the Euclid's division lemma till you get the till you get the answer. Step number 3. Continue the process till the remainder is 0. So how that means we have to continue this division process till how much? So we have to continue the division process till the remainder is becomes equal to 0. So how many times we have to do division? So we have to divide the given number till the remainder becomes equal to 0. The divisor at this stage will be a required HCF of the given two numbers. These are the 3 steps we have to follow to get the to find the Euclid's division algorithm. And simply you have to say means algorithm is you have to find the HCF of given two numbers. We can discuss. Also, we have to understand this problem while taking some examples. While solving the problems, you can understand what is division lemma, Euclid's division lemma, and what is Euclid's division algorithm. So another very most important point you have to keep in your mind. What is that point? Since the remainder becomes equal to 0, then the divisor at this stage will be the required HCF. The HCF of point number 1. The HCF of two positive integers a and b is the largest positive integer d that divides both a and b. To find the HCF of any 3 numbers, for example a is greater than b, b is greater than c, by using division lemma, first find the HCF of any 2 numbers, then find the HCF of other 2 numbers. That means the very most important note you have to keep in your mind, HCF of two positive integers a and b is the largest number you have to take. And the second point, to find the HCF of 3 numbers, say a is greater than b, b is greater than c, then HCF of a and b, just you can call it as d, then you should find out HCF of d and c, which will be the required HCF. And the very most important last point, Euclid's division lemma and algorithm are so closely interlinked that people often call former as the division algorithm also. I'll repeat again. Euclid's division lemma and algorithm are so closely interlinked that people often call former as the division algorithm also. So okay children, now in this chapter you understand in this topic 1 the very most important concept, lemma and algorithm. That is, lemma means is a proven statement used for proving another statement. Algorithm, an algorithm is a series of well-defined steps which gives a procedure for solving a problem. And what is Euclid's division lemma? Euclid's division lemma states that for given any 2 positive integers a and b, there exist unique integers q and r such that a is equal to bq plus r. And what is Euclid's division algorithm? Euclid's division algorithm, it is a technique to calculate HCF of 2 given positive integers. Okay student, now we can solve the problems based on this topic. Shall we start the problems? Here in exercise 1.1 we can take the first problem. 135, find the so take the NCERT exercise 1.1. Use Euclid's division algorithm, find the HCF of 135 and 225. Here we have to find the HCF of 2 given numbers using Euclid's division algorithm. Euclid's division algorithm. Now you understood algorithm is it is a technique to find out the HCF of any 2 given numbers, right? So the given numbers, here the given numbers are 135 and 225. Now we can use the Euclid's division lemma first. So we should find out the HCF of use Euclid's division algorithm, find the HCF. So take the 2 numbers, the given 2 numbers are 135 and 225. So 225 is divided by 135. 135 ones are 135. What will be the remainder? The remainder here 90. Again take that number, divide 135. 90 ones are 90. The remainder will be 45. So because we had to continue the division process, still the remainder becomes equal to 0. Again we should divide 90 by 45. 45 twos are 90. At the end of the division process, we get the remainder will be 0. See, if you applied Euclid's by using Euclid's division lemma, what is Euclid's division lemma? A is equal to BQ plus R. A is equal to BQ plus R. What is your A? A is always, you know that A is always greater than B. 225 can be written as, this is the divisor, this is the dividend, this is the quotient. 225 can be written as divisor into quotient plus remainder. 225 is equal to 135 into 1 plus 90. Again, because while you are continuing the division process, the remainder here not equal to 0. Again, 135 can be expressed as 90 into 1 plus 45. So, dividend is equal to divisor into quotient plus remainder. Again, next 90 can be written as 45 twos are 90. What is the remainder? 0. Then remainder is equal to, we get at the end of the division process, remainder will be 0. 90 is equal to 45 into 2. This is also we are expressing A is equal to BQ plus R. So according to, by using Euclid's division lemma, remainder will be 0. Therefore, HCF, what is HCF? The HCF of highest common factor of the two given number. What are the given numbers? 135 and 225 is 45. This is the HCF. HCF of these two number is 45. Okay, now let us take the second problem. What is the second problem? Find the HCF of the two numbers. What are the two numbers? 196 and 38,220. 220. Use Euclid's division algorithm to find the HCF of the two given numbers. Here also the same step we have to follow. The given number is 196 and 38,220. A always greater than B. That one we know that your A will be a 38,220. So the 38,220 is divided by 196. 196 ones are 196. If you subtract 196 from 382, you will get the number. Remainder will be 186. Again you bring down to, again 196 9s are 1764. Again we know the division process, subtract 1764 from 1862. We'll get 98. Again bring down 0. So 980. 196 5s are 980. The remainder will be a 0. So we can express this is in the form of A is equal to BQ plus R. Euclid's division lemma. For any two positive integer that exists a unique real numbers Q and unique integers Q and R. 38,220 is the product of 196 into 195 plus 0. 196 is a divisor, 195 is a quotient, 0 will be a remainder. Here the remainder is equal to 0. Then HCF of the two numbers 196 and 38,220 is 195. What is the HCF? Sorry, what is the HCF? The HCF of 196 and the HCF of 196 and 38,220 will be a, the HCF will be 196. Okay, next class we will discuss about another problems or next concept. So it's a very easiest chapter. Once again you go through it, the problem, solve the problems correctly. It's a very easy. 38,220 is equal to 196 is nothing but dividend is equal to divisor into quotient plus remainder. Therefore, HCF of these two given number is 196.